Hello, welcome to the video. This section, we're looking at 5.4, and we're going to be solving radical equations and inequalities. So, one of the things that we're going to be asked to do, or the question we're going to have to answer is how can you solve radical equations? Well, in order to do that, one of the things that we have to do is we must be able to isolate our radical to one side of the equation if necessary. There may be some instances where you can't, and you just have to uh, then raise the power to the appropriate side to eliminate that root. But uh, for the most part, as long as you just have one root value, isolating shouldn't be so bad. The next thing you're going to do again is you'll raise it to that power. That power will then eliminate those things, and then we can check our solutions from there. So, looking at these two examples, for instance, it has 2 times the square root of x plus 1 is equal to 4. So, isolating this radical, I'm going to divide 2 to both sides, which then leaves me with the square root of x plus 1 is equal to 4 divided by 2, which is 2. So now that I have this situation out, now I'm going to square both sides, because squaring both sides of a radical cancels each other out, so now I just have x plus 1. And then 2 squared is 4. Subtracting 1 from both sides now allows me to solve for x, and that means I get 3. And again, you can check your answer. So if I put 3 in here for x, 3 plus 1 is 4, square root of 4 is 2, 2 times 2 is 4, checks out. So if I look at example B here, I have cube root of 2x minus 9, minus 1 is equal to 2. So because this minus 1 is on the outside of the radical, I can isolate that first. So now I got the cube root of 2x minus 9 is equal to 3. Then here, because it's third root, I'm going to raise it to the third power, which will then cancel. So now I got 2x minus 9 is equal to 3 cubed, which is 27. 27, so then I add 9. So now I got 2x is equal to 36. Divide everything by 2. So x is 18. Again, you can check up on the top here, put 18 in there. 18 times 2 is 36 minus 9, 27. Cube root of 27 is 3. 3 minus 1 is 2. So it does check out. So here, a bunch of other ones. So we go ahead and solve. Isolate. So now I got the cube root of x is equal to 3. Raise things to the third power. So now this is x is going to equal 27. Over here, you're going to square both sides. So now I got x plus 25 is equal to 4. Subtracting um, 25 to both sides, x is going to equal what? Negative 21. Over here, I divide 2 to both sides. So now I got the cube root of x minus 3 is equal to 2. Now I just raise things to the third power to get rid of my radical. So it's x minus 3 is equal to 8. Add 3 to both sides, x equals 11. And again, you check your answers to make sure that they are, in fact, um, solutions. So now with a question like this, especially when you have a variable that is both um, inside a radical and outside of the radical, there is the possibility of getting some extra answers. And so what you have to do is figure out if those any of those extra answers actually work into the original formula. So anytime you get extra answers that don't work, those are extraneous solutions. So you gotta double check. So here there is nothing else that I can do with this square root. It's isolated, so I'm just going to square both sides. On the left-hand side, x plus 1 quantity squared. Remember, if you expand that, that's x plus 1 times by x plus 1, and you have to FOIL it. All right, so on the left-hand side, it's going to be x squared plus 2x plus 1. And then it's going to be equal to square root of 7x plus 15 quantity squared is just 7x plus 15. Now, because I have this x squared, what we have is a quadratic. In order to solve this, we must set the equation equal to 0. So I'm going to subtract 7x, subtract 15. So now I got that to both sides. This cancels, this cancels. So now I got x squared minus 5x minus 14 is equal to 0. All right, so hopefully we can factor this out. So parentheses, parentheses, I got x here. Signs are going to be different. Larger numbers attached to the minus. Two values give me a product of 14, but difference is 5 is 7 and 2. So I go here, zero product property is x equals negative 2 and x equals positive 7. But now we have to check. So if we go back to our original problem, and let's say I put negative 2 in. Negative 2 plus 1 is negative 1. All right. And I go on the other side. 7 times by negative 2 is negative 14. So I got negative 14 plus 15, which is 1. Square root of 1 is 1. Well, negative 1 doesn't equal 1. So this is an extraneous solution. So it's not going to work. Let's take a look at 7. So 7 plus 1 is 8. 7 times 7 is 49, plus 15 is 64. Square root of 64 is 8, and 8 does equal 8. So the only answer that works is x equals 7. So be sure that you check your work to make sure that you're getting the correct values um, for those different equations. And usually you're going to get some kind of extraneous solution, especially when you have a variable on the outside of a radical and a variable on the inside. Okay. So looking at um, this one here, both my variables are in the radical, but there is probably a possibility for a extraneous solution because um, I can't isolate my radical. So what I'm going to do is we're just going to square both sides right off the bat. So the easier one to do is the right-hand side. So the right-hand side is going to be just 3 minus x. All right. The one that's a little bit more challenging is the one on the left-hand side. So what we're going to do here, just so you can see it better, is I'm going to expand it. So this is the square root of x plus 2 plus 1 times it by the square root of x plus 2 plus 1. So I'm going to FOIL that out and then go from there. So when I multiply those two values together, I just get x plus 2 because I just took the square root out. Now I'm going to take my outside values, and then this turns into plus square root of x plus 2. I go to my inside value. This is plus square root of x plus 2. And then 1 times 1 is plus 1. What I have here is like terms. All right, so they have the exact same stuff in there, and this is, remember, this is represented as 1. This is represented as 1. So I got x plus, and now it's going to be 2 times the square root of x plus 2. And I got like terms here and here, so that's plus 3, and that equals 3 minus x. Okay, so what we are going to do now is we are going to attempt to isolate this square root. So I'm going to subtract 3 from both sides, and I'm going to subtract x. So this gets canceled, this gets canceled. So now I'm left with 2 times it by the square root of x plus 2, and this is going to be equal to negative 2x, because these cancel right at the moment. And then I divide everything by 2, so now I got the square root of x plus 2 is equal to negative x, because negative 2 divided by 2 is negative 1. And then I go here, and now we can square both sides. So now what I have is, move this over this way, square root of x plus 2 quantity squared is just x plus 2. And negative x squared is going to be equal to positive x squared because of, if you recall, using this squared gets attached by both the negative 1 and it gets attached to the value of x. Negative 1 times negative 1 is positive 1. So now I got x plus 2 is equal to x squared. So now what we have is another quadratic because I have this x squared. All right, we have to set our equation equal to 0. All right, I'm going to put everything on the right-hand side because I want my lead coefficient to be positive. So it's going to be 0 equals x squared minus x minus 2. I just subtracted x and subtracted 2 to this side over here. Let's see if I can factor this. So this is going to be x, and this is going to be x. Different signs. Product of 2, difference is 1. Large numbers attached to the negative, 2 and 1. So zero product property tells me that x will equal negative 1 and x will equal a positive 2. So again, we have to check our original equation to see if it works out. So if I go here, negative 1 plus negative 1 plus 2 is 1. Square root of 1 is 1. 1 plus 1 is 2. And then I go over here. This is 3 minus a negative 1, so that'll give me 4. And square root of 4 is 2. So that checks out. So negative 1 does in fact work. So let's see if 2 is going to work. So 2 plus 2 is 4. Square root of 4 is 2. 2 plus 1 is 3. On the right-hand side, I get 3 minus 2 is 1. Square root of 1 is 1. So 3 does not equal 1. So this is a scenario where the positive value is actually my extraneous solution. All right. Again, let's look at another one. Let's look at this one here. This one's very similar to the problem that we just did. If you have questions on 5 or 6, again, please comment. I'm more than happy to work those out, but for the most part, people have a um, pretty good idea of solving those problems. But some people just need a little extra practice on ones like number 7. So here we are going to square both sides. Like I said, I'll just move it over here. The easiest one is the one on the right. It's just going to be x minus 2. Over here, this gets expanded to square root of x plus 6 minus 2 times it by square root of x plus 6 minus 2. So looking at this, square root of x plus 6 times by square root of x plus 6 is just x plus 6. Here turns into negative 2 times by the square root of x plus 6. Inside values is negative 2 times by square root of x plus 6. And negative 2 times negative 2 is plus 4. So I have like terms here and here. I have like terms here and here. So I'm left with x minus 4 times by the square root of x plus 6 plus 10 is equal to x minus 2. So now this particular portion of the equation, now we get to isolate this x square root of x plus 6. So in order to do that, I'm going to subtract x, subtract 10, subtract x, subtract 10, cancels out. This actually cancels out. So now I'm left with negative 4 times it by the square root of x plus 6 is equal to negative 12. Divide everything by negative 4. So now I got the square root of x plus 6 is equal to a positive 3. So from here, I get to square both sides. So now I got x plus 6 is equal to 9. Subtracting 6 from both sides, x equals, looks like 3. So see if it works out. 3 plus 3 is 9. Square root of 9 is 3. 3 minus 2 is 1. And then 3 minus 2, 1. Square root of 1 is 1. So it checks out. All right. So yeah, it kind of looks a little bit scary just because it has a fractional exponent, but you're going to follow the same rules as you did with radicals, all right? So you're still just going to isolate this raised power. So subtracting 2 from both sides, so now I got 2x raised to the 3/4 power, and that's going to be equal to 10 minus 2, which is 8. Now, what we want to do is we want to get that variable to have a exponent of 1. So what we're going to do is we're going to raise it to a power that's going to make it 1. So what I'm going to do is I'm going to raise it to the reciprocal of 3/4. So that's why I'm going to raise this to the 4/3 power. And since I did that to the left-hand side, I must do that to the right-hand side as well. So what that does is it cancels these out to be 1, so I'm left with 2x on the left-hand side, and 8 to the 4/3 power is going to get us 16. Now that it's just 2x is equal to 16, I get x equals 8. Here, same idea. Isolate it. It already is, so the reciprocal of 1/2 is 2, so I'm just going to square it. So now I get x plus 30 right here, and then this is going to equal x squared. Because of that, because of the x squared, we have a quadratic, so we have to set it equal to 0. I'm going to subtract x and subtract 30, so now I got 0 equals x squared minus x minus 30. And so I go 0 equals parentheses, parentheses. I got x here, x here. There are different signs. Product of 30 difference is 1. This will be minus is going to be with the 6. This is going to be with the 5. So x is going to be negative 5, or x is 6. And again, you're going to check your solution. So if I go negative 5 plus 30, I get 25. Square root of 25 is 5, and I get negative 5 here, so 5 does not equal negative 5, so that is an extraneous solution, and I believe 6 is, so x plus 30, 36, square root of 36 is 6. 6 does, in fact, equal 6, so that works out. And the last thing is talking about inequalities. Inequalities follow the same thing as equations. You're going to do everything the same. You're going to isolate. You're going to raise it to the power appropriately to solve for the variable. So again, you're going to add 3 to both sides here. So now I got 2 times by square root of x, which is greater than or equal to 3 plus 3, which is 6, divided by 2, square root of x is greater than or equal to 3. I got my square root isolated, square both sides. So now x is greater than or equal to 9. And remember all rules of inequalities. So if you multiply or divide both sides by a negative number, you have to flip the inequality. Please remember that. Here I got to divide by 4. So now I got the cube root of x plus 1 is less than 2. So now I raise this to the third power, raise this to the third power, so I'm left with x plus 1 is less than 8. Subtracting 1 from both sides, x is less than 7. And that is being able to solve radical equations and inequalities. Hope this helps. Till next time.